Hi, beautiful people. Thank you for coming to our new class. So we are in week number 5. This is the second class. Let's see what we got for today. I'm going to start off by asking you, uh, what type of function we have been graphing so far. So you are used, guys, to see something like this, right? Okay, we got the coordinate system. Okay, let me just draw this. The coordinate system, something like this. And the type of graph that we got are something like this. When the slope is increasing, we can have another type of graph that is something like, let me give an example, something like this as well. What other type of function do we have so far?
And zero.
The constant, the zero slope, there are constant functions. That's how we call them, constant functions. They don't have a slope, they're constant, like this, something like this. These are the three type of graph we have seen so far. And how do we graph then, guys? We have three methods, which is the table. The second method is slope intercept form. And the last one was the intercepts, right? When y is 0, we will find it at x-intercept, etc. So, but now, guys, I'm going to ask you, okay, take a look at these graphs, okay? What do they have in common? So all of them are lines, right? Okay, good. So, but now I'm going to ask you something. This is a graph, guys. Mister, are you kidding me? This is supposed to be a graph? Yes, this is a graph. So what is the difference, guys, between this one and the three previous examples that I showed you?
This one no, is
They have
not
more
a
points.
straight line.
One
It's
is,
I
straight line.
have
yeah, this one's not a
it's
straight.
not a
It's like changing about direction.
okay, it's a straight line. Yeah, good point. I got that. It is not like a single straight line. We got this part, this one is different, this one is different, right? Ah, interesting. So let me show you another one. What about this one? What do you get to see in this one?
It's a curved line and a straight line
Curved.
too.
Oh, this is even different. We got a curved line, which is something we haven't talked about. We got a constant function without a slope, and we got a straight line. Oh, this is crazy. Are we gonna look something like this? Yes, we're gonna work with some type of graphs like these guys. So, but this is the idea, guys. The main thing here in this kind of function is that this function is one until one point. Then at this point is another function, and this is another function. So, and how do we call this? Okay, we have this is today's topic, piecewise and step function. So what is that, guys? This, when you see this title, guys, this piecewise functions are the type of function that I just showed you, that we have like in different parts. Some part, this piece is one function, the other piece of the graph is another function. You have different pieces that makes a single graph. So this is piecewise and step function. You can find information in page 259. And what is a piecewise linear function? So it's just a graph which has a graph that is composed. There's composed son of, sorry, I don't get to see the of here. So that is composed of some numbers of line pieces, number of linear pieces. What is that? It's exactly what I show you. You have one piece here, you have another piece here, and you have another piece. Okay, you have different types of pieces. So in order to form the single graph. So basically that's what I want you to write down. So let's have a look at this. We are asked to graph. That is the $1,000,000 question, guys. We need to learn how to graph these functions, and this is different. Take a look, guys. This function it looks different. Can someone tell me what is the difference, guys, between this and the previous functions? So what is new here in these functions?
This is like we have like that if x and x equals greater what greater, and we have like two equations.
Excellent. That is the main difference. So we got more equations. We got one, two equations. And then we have a condition. If x is greater than something, if it's a conditional, right? So it's like a constraint. It's like an order. If you're gonna do this, if I'm gonna give you money if you do your homework. I'm gonna do this if you, etc. So in order to understand that, I'm gonna give you a short review, guys, about the conditional. Let's have a look at something. Let's suppose, guys, I got a number line here. I got a number line here. So, and I tell you, guys, okay, let's suppose that this is the number 0, 1, 2, 3, 4, -1, -2, and -3. I'm gonna tell you. Okay, this is. Let me think about something. So this line represent money. So this line represent dollars. So I have dollars here, some dollars. So I have some dollars here. So and I tell you guys, this is like my money. So you can take guys, more. Okay, I'm gonna tell you. You're gonna take more than. Let's suppose that this is X, right? This is X. You're gonna take more than $3. You can take more than $3. Okay, what values can I take, guys? More or equals than 3. Okay, X greater than or equals to 3. So which values can I take, guys? Do you think that if I take 0 and I'm going to be evading that condition, X greater than or equals to 3? If I set this value here in 0, am I going to be, I mean, respecting the condition?
No. I don't
No,
think.
right? Because this is telling you clear. This is clear. X greater than 3. Okay, you can take, guys, $4. Okay, that's okay, guys. It's better for you. So, can you take $4.5 here in the middle?
Yes.
Yes. Can you take 3.5 here?
Yes. Yes.
Can you take 3.1, $3.01 and 1 penny?
Yes.
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 Can you take $3? X or greater than this line here, less than, greater or equal, this little line here is telling you that you can take $3. Okay, that's okay. So guys, you can take all of these, guys, greater than. Okay, this is exactly what I wanted to show you. So you can take all of this, all to the right, right? You can take $1,000 out of my bank account. Oh, that's good. So what about, let me give you another condition. Now let's say that I tell you. So you can take, guys, only less than $2. Listen up. This is X less than 2. It's a condition, guys.
So
So,
we're gonna like
mhm.
we're gonna take like the ones that are from -2 up and like that. Yes.
Okay, you got it. So we're gonna take values less than. This is telling you guys this is greater and this is less. This value is less than. Okay, less than 2. Okay, you can take $1, guys, because if you take more than, it's like when you go to the grocery store and your mom tell you, okay, go and buy me some things. Okay, buy me this and this and this and this, and you can take 2 lempiras. You can buy something less than 2 lempiras. Okay, you can take, guys, 1 lempira. Okay, you can take one. Okay, $1. So you can take 0.5 and buy a what? A candy, a Vualu, 0.5, right? 50 centavos, 50 cents, right? You can take a one of these guys. You can take all of these, and you can take even nothing. You can take all of these, guys, to the left, less than 2, guys. That means that you can take these values, these values, these values, these values, until 2, guys, but you cannot take more than 2, guys. In this case, you can't take the 2 actually because it's less than 2. That's why I leave an space. I leave an space because I can't take 2. I just make a circle, an empty circle. In this one, I included because you could take it because of this one. Because of this one, you can take 3. When it is not, when you don't have this little line, the equal sign, so you leave it in blank, like this, empty. Basically, guys, this is a condition. And what are you explaining this, mister? Because we're gonna need that condition in this case. So first of all, guys, don't get scary, guys. Don't, I mean, fear not. Just because we have to function. What we're gonna do essentially, guys, is just take the first function. Let's erase the second one. Okay, I'm gonna erase the second one. Okay, can you graph this? Y equals 1/3 of x plus 2. If x is equal, yes, you can graph that perfectly. Okay, let's graph it. Again, we're gonna focus in the first equation. Forget about the second one. I'm gonna call this the first equation. Okay, this is the first equation. Okay, I'm gonna work with the first equation. Can someone tell me, guys, which method are we gonna use? Table, intercepts. In this case, guys, I highly recommend to use the slope intercept form. So what do we need, guys, when graphing by using the intercept form? We need the y-intercept, and we need what else? And the slope, right?
Slope. Yes.
Okay, what is the y-intercept in this function, in the function y? What is the number alone without variable?
2.
Is the number 2, correct? Is the number 2. And what is the slope in this function? What is the x coefficient?
1/3.
It's always a fraction. We got the fraction already, 1/3. Okay, guys, with this information, we can graph the first one. Okay, let's do the coordinate system and graph it. Let's make it. Okay, once we got a coordinate system, we're gonna graph this. The y-intercept, guys, this is the basic idea, guys. It's exactly what we have been doing. The y-intercept is 2. Okay, let's look where this graph is gonna cross in y. Y equals 2, guys. You're gonna tell me stop when I have to stop.
Stop.
In 4, no, shame on you. It's
Teacher,
in 2, guys.
sorry. How do we know why?
is that you cross the line.
Teacher,
Yeah.
sorry. How do we
You're
know
scared.
why intersection is 2?
Okay, y-intercept is 2, guys, in y, right? In y at 2, y positive 2, okay? And then we need to move according to this slope. This slope is positive, okay? I remind you guys that numerator tells you what? The change in x, in y, sorry, and the denominator tells you the change in y, okay? How many units in y should I move from this point? One, okay, let's move 1 up, okay? We're gonna move 1 up. And how many units should I move in x?
3.
3.
3. 1, 2, 3. Okay, let's do that. 1, 2, and 3. Okay, and then here's where we're gonna get the next point. Okay. Okay. With these 2 points, guys, it's the same, guys. It's actually the same. I'm gonna erase this. I don't want this to look bad. Okay, I'm gonna erase this. And then, guys, what is next? Okay, just get a ruler and make the line. Okay, we join the 2 points. We get a line. So now, guys, the only thing, okay, so far, guys, so easy. It's the same thing. So, but we got a condition, guys. We got a condition. So the condition is telling you this graph is valid only if x is greater than 2. Okay, can someone spot where 2 is? What is positive 2 in x? Let's look it. This is x. Negative 1, negative 2. No, mister, look for positive 2. It's this point, right?
Yes.
Okay, this means, guys, if it is greater, so you have the permission to graph only if this goes to the right. Greater than 2 is 2.1, 2.2, 3, etc. All these values to the right. So just greater than 2, guys. This is the condition. Okay, Mr. But you got graph in this side. So this side is wrong, guys. That's why we are going to erase this. Take a look. I am erasing it because this part is not valid. I don't have permission to graph in this side. The permission is until what? Until what value in x? In x? 2, right? x2 until this permission, guys. I have permission until this value, until x equals to 2. Okay, I'm going to stop in 2, in 2, in 2, in 2, in 2. Okay, until here, guys. X greater than 2. Okay, that's exactly what I have to do. X greater than 2. Okay, x means greater, means to the right. All of these values. And should I fill this or empty, guys? It's included. Take a look. X greater than or equal. Okay, when you got the equal sign, guys, you put it like a dot like this. Okay, in 2. Okay, and this is the first piece of the function. 1/3 of x plus 2 if x is greater than or equals to 2. I erase this, I repeat, guys, because I don't have permission to be. It's like if your mom tells you you're gonna be here, guys, I need you to be at home before 10. So you're not gonna come home 11, right? You're not gonna show up at 11. So that is exactly the condition we're using here. Just after 2, greater than 2. Okay, the graph is here. So now let's go to the second graph. Okay, we're gonna use the second graph.
Teacher, we are using the method
Can you repeat
you
the
say
question?
that you like more, right?
Repeat it, please.
We're using like the method we were seeing last week, I guess.
Yes, we are. We're using the slope intercept form because I think
That one.
it is the easier one. In order to use the intercept here, guys, will be a little bit tricky. So I think this is the best one. Okay, let's label the second equation. Okay, this is the first equation. I'm gonna work with this one. Forget about the first one. Just focus on this one. This is the second equation. Okay, let's identify information then. Okay, second equation. What information are we gonna need? The same information, which is I need the y-intercept. So I'm gonna use a different color here. So let me see if I can use the what color can I use, guys? Give an idea. Yellow. So I'm gonna use yellow. Y-intercept, and I need a slope. Can someone tell me what is the y-intercept in this function?
3.
The second one.
3.
Three.
What is 3 is the constant term, is the number alone. Thank you. And what is the slope? What is the inclination? This value with the x. Okay, it's a
Negative
fraction.
one.
And what
over
number is
one,
that,
I
Negative
guess.
guys, in
one.
the numerator? Negative 1.
Negative
Excellent.
one.
Over 1, because we don't have,
Yes.
okay, it's 1 here. Over 1. Okay, negative 1. Okay, correct. Now, let's graph it as normal, guys, as usual. Okay, the y-intercept is the first thing that I'm going to plot. Okay, the y-intercept in this case is 3. 1, 2, 3, and y equals 3. Okay, that's here. So I'm going to put the first point right there. So it's right here. And what is the slope? I remind you guys, the slope, guys, is always a fraction. This is the y, and this is x. That's changed in y and changed in x. How many units should I move in y from this point? One,
One.
right? Up or
Down,
down?
I guess. Down.
Down, because it's negative. So correct. Okay, 1 unit down. Okay, I move 1 unit down. Okay. And how many units should I move in x?
One.
1 as well. Okay. And this is where the second point is going to land. Okay. This is exactly where the second point is going to land. Okay. I'm going to put the second point here. I'm going to erase this, guys. It doesn't look that good. So I'm going to erase it. So I'm going to erase this and this. Okay. I got the 2 points, guys. Get a ruler and make the line. Okay. These ones. Okay. Let's make the line. Okay. Okay, I just joined the 2 points. This is not the best line, guys. I know you can do better. So this is a line. Okay, now we just graph it, guys, as usual. Nothing different. But we need to have a look at the condition. The condition is telling you this graph, this one, the second one, this yellow one, is valid if x is less than 2. Okay, we have the condition. Look for the value x2, guys. Where is x2, guys? It's right here, right? It says you're gonna graph if x is less than 2, guys. Okay, this graph is gonna be valid from this point, from 2 less. Less means to the left or right, guys. Less than 2. Left, right?
To the left.
Okay, correct. Okay, this part is not valid, guys. This one is not valid because this is greater than 2. I'm gonna stop until 2, guys. You tell me, should I stop? I am in 3. I
No.
need to stop in in
There.
in in, in 2, like here,
There.
right?
Yes.
No.
Yes.
So because
Yes,
the
there.
condition, tell me. The
Yes, there,
condition,
mister.
okay, thank you. The condition tells you graph this if x is less than 2, no more than 2, guys. If you graph more than 2, you're disobedient.
And
So,
in
and
two, neither two, right, mister? Because
neither
it
2,
doesn't have the
correct.
line.
It's just a limit. Okay, we need to make like a circle because 2 is, oh, it looks like an empty, okay, like this. Oh, that is big, guys. Sorry, so let me change these shapes. So it's gonna be neither 2, that's right, okay? We leave like an empty hole here. So because it's just less than 2. And this one was 2, so that's why I color it. And this is the graph, guys. One piece, another piece. Piecewise defined function. Again, we are asked to graph this piecewise defined function. So it's like we have 2 functions at the same time simultaneously. So the first thing that I'm gonna take the first equation. Okay, I'm gonna forget about the second one. This is my first equation. And I'm gonna work just with that one. So first equation is, and let's identify the information. What information do I need? The y-intercept and
The slope.
Slope.
slope. A slope is always a fraction. What is the y-intercept in this function?
4.
1.
4. 4 is the y-intercept, okay? Constant value.
Yes.
And what is the slope? The x coefficient.
2 over 1.
And I need a fraction. Mister, I don't have fraction. Just put a 1, guys. Come on, man up. Okay, we got it. Let's get the coordinate system and let's graph this. Continue. Okay, let's have a look at this one then. We got a y-intercept and a slope. Let's represent this. Let's plot those points. So what is the y-intercept? Y equals 4. Okay, y equals 4 is where the graph is going to cross this. Y equals to 4. Can someone help me and look it up, the 4 and y? Oh, it's right here, positive 4. Okay, let's make the first point right there. Okay, it's 4. Okay, like this. And now let's move according to this slope, which is 2 over 1. Okay, I remind you guys that numerators is the change in y always, and the denominator is a change in x. Okay, how many units should I move up in y?
2.
It's positive. Okay, move up 2 units. Okay, 1 and 2. How many units
2.
should I move in x?
1.
Just 1. 1 to the right.
One.
Okay, and correct. And this is where we're gonna get the second point. Okay, here. I'm gonna erase this. I don't like how it looks. Okay, I'm going to erase this part. Okay, this part. I only need the 2 points, guys. Okay, now, guys, it looks like this might be off of our graph, right? So it's going to be out of our graph. So, but let's get the ruler and graph. Let's suppose this is a straight line, guys. Okay, this is the first graph. Okay, now you just graph it, as you know. Now let's look at the condition. What is the condition for this yellow graph? X less than or equal to 1. Less than or equal to 1. Look, x in 1, guys. That's the condition. X1. Okay, at this point, this is x1. So, less than, guys, is to the left or to the right? Less than. What values are less than 1?
To the left.
To the left. Okay, guys, if you're taking x less than 1 and you're taking this side, this is wrong because you're not permitted to have those values. Okay, what are we gonna do, guys? I'm going to erase this part. I'm going to erase this part. Take a look. I'm erasing here, guys. Up. Until what point in x? Until
1.
1.
It's
Correct.
not.
Until 1. Correct. This is 1 in x. Okay, until 1 in x. Okay, and then it's less than or equal to. That means, guys, it's including the 1. Okay, we're gonna make like a point here, so we're gonna fill it because it's including it. Okay, all the values less than, take a look, less than 1. Okay, all of these values are valid. Okay, just like that. Take a look in this, Samantha, that in this case we take the graph is getting the y-intercept because that was your point in the last example. In this case, it's getting it. Okay, it's not necessarily has to be getting it on the graph. Okay, this is the first graph. Now let's go to this. Tell me.
So it is like permitted to have the other ones because it's less than 1.
Correct.
And the
Correct.
rule says that if it is more than 1, right?
Correct. In this case, it's less than, okay, all the values less to the left of this. In this case, take a look, these values are going to be greater than 1. So let's have a look at this part. I'm going to take the second equation, the blue one, this one. So equation 2, guys, is going to be y-intercept. I need y-intercept, and as well, I need a slope. What is the y-intercept in the second function?
3.
3. And what is the slope?
It's -1 over 1.
Correct.
Negative
-1
1
over
over
1. Okay. Something that I didn't mention, Mister, I don't have y here. I have f of x. It's the same, guys. It's the same. F of x is like you have in y, just in different form. Okay, let's graph this, guys. What is the y-intercept? You said it's 3, right? It's 3 in x. In 3 in y, sorry, the y-intercept. The y-intercept is 3. Okay, 1, 2, 3. Okay, I got this one, 3. And what is the slope in this case? What is the slope in this case?
1
Negative 1. Okay, that means from this point, move negative. Move 1 down. And how many in x? 1 as well, right? Okay, this is going to be the first point. -1 down and 1 to the right in x. Okay, these are the 2 points. Let's make the graph now. Okay, and this is almost what I was looking for. This is the graph, guys, for the second one, the blue one, negative x plus 3. This is the graph. Now, guys, let's look at the condition. The condition says this function is valid if x is greater than 1. Okay, go to 1, go to 1, go to 1, and greater than. Okay, only these values to the left from this point. Okay,
Yes.
this is less than 1, guys. Okay, I'm going to erase this one because it's not valid. This is not valid. This is not valid. Be careful. Don't erase the yellow one. Oh my gosh, I did. Sorry. This is one of the disadvantage. Okay, let's have a look then. So I'm going to erase that one. Okay, I erased that much. Sorry. I didn't mean to. So let me see if I can erase this, guys, properly. I can erase this, I can erase this, I can erase this. And then I'm going to stop until what value, guys?
1.
Until 1.
1.
Okay, here, right? This is 1, right? It's at this point. Okay, this is 1. Only greater than, okay, this value, this is greater than 1. This is valid. Okay, and then, guys, here I'm going to fill it or not. I'm going to leave it empty.